Hello guys, now in this video we will be mainly looking what dataset we are going to work on. So we will use the dataset which is available on Kaggle for sentiment analysis, which basically consists of a sentence and its respective sentiment as a target variable. And this dataset contains basically the three separate files named train.txt, test.txt and val.txt. So in order to look the dataset, so you can just see it here. So these are the three files, which is test file, train and validation. Now if I click on test, so you can see this is the file. So basically your dataset looks like this. Just maximize a bit. So you can see how the values are given. Each line represents a new row. So it contains few. You can see it is a very big dataset. And similarly we have for train and we have for validation. Now basically again, as a normal machine learning problem, we will read the training data and validation data as a data in the text format separated by semicolon, and without column names we will create the data frame with read underscore CSV function and parameters as delimiters and names. Now for reading data we have to just type df underscore train equal to pd dot read underscore CSV train.txt file name. And one more thing before we work on, I have already uploaded the data set into this particular file. So when you have to just click on this particular file, it will ask for the data set. You have to just click on it and it will give you the following results. It will just get uploaded here. Now you have to just call here in order to process the data in your Python library environment. So where was delimiters is basically semicolon, as we have just seen our data set. Names, because we want to get the names to columns. Names equal to square brackets, we will give names. So what we will giving, first one definitely be the text followed by label. Yeah. Now let's repeat the entire process for addition set. Now just change this name to val and this to val.txt. Now when I run this piece of code, okay, now it has been, the data set has been loaded into train and validation. Now we will concatenate these two data frames, as we will be using cross validation and we have a separate test data set. So we don't need separate validation set of data, and then we will preset the index to avoid duplicate index. So for that we have to just do df equals to pd dot concat in the circular brackets df, that the data set we will be concatenating, comma df underscore one. So we will be concatenating these two data sets, and now we have to reset the index. So we have to do just this index and then in place equals to true, because we want capital T, because we want to make this happen in the entire original data set. We don't want a copy of it, so we have to place it in place equals to true and drop equals to true, because it will done for the original data set. When I run this, so that's fine. So we can view a sample of the contents of the data set using the sample methods of the pandas and checking the number of records and features using the shape method. So in order to see the shape, so you can do print, you can write shape of the data frame, and you can pass on df.shape, hit enter. You will be able to see there are 18,000 rows, the 2 columns, which are namely text and label. And if you want to see some rows of it, so you just need to type .head, and these are your rows. This is how your dataset looks like. Now we will check for the various target labels in our dataset using the cbound library. So for that, we have to just type cns.count.plot, and we have to specify label in order to visualize it. Shift the center, and shift the center, and you can see. So as we can see, we have 6 labels or targets in the dataset. We can make a multi-class classifier for sentiment analysis, but for the sake of simplicity, we will merge these labels into 2 classes, that is positive and negative. So positive may include words like joy, love, and surprise, and negative can include like anger, fear, and sadness. Now what we will do now, we will create a custom encoder to convert categorical target labels to numerical columns, that is 0 and 1. Now for creating the encoder, let's just define a function. So def custom encoder, to pass def. On the function we have to write def dot replace to underscore replace. We have to replace the surprise, comma, value equals to 1, comma, we have to specify in place because we want to make this happen in the entire data set itself without creating a custom copy. True. We just copy it. Paste it, paste it, paste it. 1, 2, 3, 4, 5, 6. Now I'll just need to replace the values. Okay, now the surprise will change to love. This will change to joy. This will change to fear, anger, and sadness. When I press shift press enter, this piece of code run. Now you have to call it, that's why I've already written it, custom underscore encoder df label. Let's run. Now you want to plot it again, so we again use sns.countplot df.labels. And this is the output function. As you can see, we have converted these words into 2 categories, which are just 0 and 1. 0 for negative and 1 for positive. And the data is more or less in a balanced state. As you can see, both the values are somewhat closer to each other. Now, next step that we're going to do is basically data preprocessing. Now we will perform some data preprocessing on data before converting into vectors and passing it to our machine learning model. So we will create a function for pre-processing data. So we will follow a series of steps. The first steps, we will iterate to each record using a regular expression. We will get rid of any characters apart from alphabets. Then second thing that we are going to do, second step, is we will convert the string to lowercase, as the word capital God is different from the word small god. That's why we need to convert everything into lowercase. Because without converting to lowercase, it will cause an issue when we will create vectors of these words, as 2 different vectors will be created for the same word, which we don't want to. And step 3 will be, then we will check for the stop words in the data and get rid of them. Stop words are commonly used in word sentence such as the, and, to, etc. which we do not want to, which do not basically add much value to the sentence, and we have just already seen. And finally, then we will perform lemmatization on each word. That is, change the different forms of a word into a single item called a lemma. And as you might have heard, a lemma is basically a base form of a word. For example, run and running, running, and runs runs are all forms of the same lexeme, where the run is the lemma, because runnning, and runs will get short into run, which is the lemma. Hence, we are converting all occurrences of the same lexemes to respective lemma. And finally, then we return a corpus of preprocessed data. But first, we will create object of WordNet lemmatizer, and then we will perform the transformation. So for doing that, we have to just try. First of all, let me just comment object of WordNet lemmatizer. Now we have to create it by lm equals to word. Okay, it has already appeared. Now we have to create function. So def txt underscore transformations df underscore call, and set is, let's take corpus. This is a simple bracket. Now I want to iterate over my entire dataset. So for that, I'll do for item in df underscore call, and I want to do item equals to t dot sub, using basically regular expressions. I want to push the bracket. Set capital A, C, use bracket, comma, empty string, comma, str for the item. Again, I'll do this for equals to new underscore item dot lower, and again the next step, that is step 3, was new underscore item dot split, and final step was to lemmatize. For that, we have to do lm dot lemmatize word for word in new underscore item if word not in. You might be wondering what logic I am using. You guessing it what I'm doing? Yeah, I think you might have guessed. For the stop words, we have already seen this piece of code. Stop words dot words, and again we need to specify which particular words we are dealing with. As you know, English. Yes, so we specify English. Now finally, we have to append corpus dot append on the join strx for x in new item. Now finally, we want to return. So return corpus. Yes. And run a piece of this code, and it has run. Now for checking, what we can do is just take corpus equals to call that function transformation, and we're going to parse df, and suppose let's parse the word txt. So there's an error. Oh, sorry, I passed the wrong. Text.transformation. It happens. Errors gets caught. Shift plus enter. And now you can see. So guys, I just found that there was some sort of issue with it, in which, like, when I was initialized, when I have initialized with the LM with the word net limitizer, I forgot to put spaces. That's why I caused me a bit error. Another thing is, like, these are the libraries, stopwords, wordnet, and OMW 1.4 that you need to implement before running this function. So I imported it again, and when I run this function, and then when I run this statement, it is good to go. And this statement, when I run this, it will take quite time. So let's just wait. So it is basically following each step in our function that we define. First, it converts into with the sub expressions, regular expressions, then it converts each into those case, then it splits the word, then we apply the limitizer function, and finally we append that particular word to the corpus and we return. Let's just wait, and yeah, that's finally. So now we will create a word cloud. It is a data visualization technique. Again, now we are talking about the word cloud. So it is basically a data visualization technique which is used to depict text in such a way that the more frequent words appear enlarged as compared to less frequent words. That is, the words which are more in your dictionary will appear larger and bigger. The font size will be a sort of bigger compared to the words which are appearing less. So their font size will be somewhat smaller. So this gives us a little insight into how the data looks like after processed through all the steps until now. So for that we have to do RC params. We have to specify the figure size. Let me just specify. I want figure fix size because I want to be around. Let me just keep it. Let's just take 20 and 8. That will be good. Now I have to take, instead of RC, I just easy. It's fun. Cloud equals to empty strings. Again, now for row in corpus size plus, and again use for word in row. Right, take hot cloud, incrementing it with the dot join operation. Finally, want that word cloud to be presented. So word cloud equals to word cloud specify width. For word cloud we need to specify width. So 1000 gi. Height will be, I'm going to take 500, and background color will be white, and I want some more arguments. I'll have minimum font size also defined. That is, the smallest size of any word should be at least 10. Close this function. This dot generate word underscore. Okay. Now, as we know, in order to show, we have plt dot I show, and we need to pop. Yeah. When I run this, get an error. What says? Or acha, sorry. Because so basically RC params we have not defined. So for that, what we just have to do is to just import RC params from matplotlib. So you just need to add this piece of code there. From matplotlib, you have to, when I employed style, I forgot to import RC params, so we have to import it RC params as well. Then we can just use any sort of style. Again, I gave the default style as 10.5 if not specified, but I am using currently 28. So now if you can see, this is what a word cloud looks like. So you can see the word feeling was perhaps the most use of words in our dataset, followed by feel, and you can see the small words like see. You can see is here better. You can even see word I, very short. I don't know if you can see or not. I can see I. So basically, the more frequent the words are, the larger their font size. So this is what word clouds look like. So this was in the second video. Now from the next video, we're going to deep dive into the bag of words, which is another set of topics, and we'll carry on from there. So thank you.